Hi, my name is Rebecca, and my project was looking at the conditions that affect the burn times of slash piles, specifically looking at Radiata pine. So the problem that I was looking at was that slash piles tend to take up a lot of space, either on landings or off the sides there on slash banks. These areas do have the potential of being replanted, as forest managers are always trying to maximize the space they have available to them. Slash also is unstable when left on slopes, as we all know from Cyclone Gabrielle and all of that. And options to get it to options to have it removed can be quite expensive as well. The objective of my project was to investigate how long it took for these piles to burn and then be completely out. The definition for out was that it was cold to touch with the back of your hand safely. And the characteristics that I was mainly looking at for this was weather, fire weather index, pile size and contents, as well as the initial moisture contents of the piles as well. How I did this, so initially went out to, these slides are in the wrong order. I'm just going to go to these. So my two locations that I was looking at, first one was Tinamu Forest, owned by Isla One, and Craig Dean Forest, owned by Forest 360. So on the left-hand side there, we have Craig Dean Forest. I was specifically looking at those top 4 piles there. The ones in red as of the 17th of September were still burning, and the one in green has been called out. On the right here, we have Tinamu Forest. I was looking at the 4 piles circled in red there, and all of those have been called out. Going back to my methods, so what was originally done was we went out to site, flew a drone over the piles, and collected a whole heap of photos. I also collected some wood samples and brought them back here to determine the moisture contents. The piles were then ignited and left to burn, and during that time I was collecting weather and fire weather index data. From the 17th of September, these were then gone back to, and drones were then, and a drone was then flying back over the pile collecting a second set of images, which I was then able to put into 3D models such as the one here. And from that, I was able to determine the pile sizes and the contents of the piles. These are the start of my results. We're looking at pile size in the top one here and pile contents in the bottom. So piles 1, 2, 3, 4, and 9 are the ones that have gone out. And as you can see, the sizes of these piles are quite varying. Piles 1 and 2, 2 and 3 are quite small compared to piles 9 and 4 of the ones that have gone out. And looking at piles 6 and 10, which are smaller than those, it can be determined that pile size isn't a really good indicator of how long they could burn for. But looking at the pile contents down here, which I was only able to get for Craig Dean Forest, pile 9 is the one that went out, and as you can see, the heavy fuel contents there is quite a bit lower than the others, while the finer fuel contents is higher, as the finer fuels are the ones that burn out quicker compared to the heavy fuels which burn for the long duration. So suggesting that having the less heavy fuels means that they do burn for the shorter amount of time. This table here shows the initial moisture contents of the piles, and this one wasn't a really good reflection either, as pile 9, which was the one that went out in Craig Dean compared to the other 3, has the highest moisture content, which was quite a surprising find. I was expecting that one of the lower ones, like pile 6 or 11, would go out first, as you would assume that having lower moisture contents mean that they would burn through the fuels faster, but this hasn't been the case here. Moving on to weather data, rainfall was one that was really important here. The two lighter lines at the start there were the start dates, the first one being Tinamu, the second one being Craig Dean Forest. This first black line here after the 44 mils of rain is when all of the Tinamu forests were piles were called out. And then after the next rain event of 26 mils, that was when pile 9 and Craig Dean was called out. So this is a really good indicator that rainfall could be a contributing factor. The main fire weather index code that I was looking into was the drought code, which is the indicator of how easily heavy and deep fuels ignited and the intensity that they burn at. At the start of the experiments here, everything was sitting above the extreme level, which is above that 300. And then as they dropped down into the very difficult, moderate, and then into the easy. And as you can see, as the piles are starting to get called out, they are dropping into the lower thresholds there. But as well as you would expect that as they are sitting quite high and only just dropping into the lower threshold towards the end of September there, that you would expect these piles to still be burning and due to these heavier fuels still being easy to ignite. So in conclusion, the main indicating factors that I found were the pile contents, rainfall, and drought code, while factors that weren't so good at indicating how long these piles would burn for were the pile size and the initial moisture contents. There were a few limitations to the study. One was the availability of the drone images. This led to inconsistent pile measurements, as I did the size of the piles for Craig Dean was based off the drones, while the ones for Tinamu were done off manual measurements of us going around the piles and measuring them. This also meant that I couldn't do a pile contents analysis for Tinamu Forest, hence why I could only present the Craig Dean Forest pile contents. And when I was processing the drone images for Craig Dean, I had some spatial alignment issues, and so I had to manually bring the before and after images to match each other, which could lead to some errors in those pile sizes. The final limitation was not having a definition of out, and this left it open to some interpretation. So those Tinamu piles were actually called out once they had gone through and done all of their replantings for the year. And they just planted into those burnt areas as well. Whereas with Forest 360, they were going through and checking that different spots around the pile were cold as well. Lastly, I'd just like to thank Forest 360 and Lyall 1 for letting me use their forest as a test site and helping me out collect all my data. Thank you.